So let's talk about our standard vertex form for a second. I just want to review something. Okay, so if we're looking at the vertex form and our Q is 0, how many x-intercepts will we have if Q is equal to 0? Whether it's opening up or down. So let's think about that. If Q is 0, that means that our vertex lies where? Somewhere on the x-axis. So if it's somewhere on the x-axis, like for example, it could be here, or it could be opening down, right? All of these are an example of a Q value of 0. How many x-intercepts will we have? Just one. Okay, so let's talk about this. If Q is positive and A is positive, is this graph opening up or down? Up, good. And if our Q value is positive or a greater than 0, if it's opening up and we have a positive Q value, how many x-intercepts will we have? Will it touch the x-axis? No, so to have no x-intercepts, or none. Okay, what about a graph where A is negative, so we're opening down, but our Q value is positive? Is it going to be above the x-axis or vertex or below? Above or below if our Q is positive? Above, but it's opening down, so our graph is going to look something like this, meaning how many x-intercepts would that be? 2. What about the next one? So Q is less than 0, meaning the vertex is above or below? Below, and it's opening up or down? Up, because A is positive, meaning how many x-intercepts? 2. And last, if our Q value is less than 0, means our vertex will be below the x-axis, but we're opening what direction? It's less than A is less than 0. Up or down? Down. So for our Q value, our vertex is below, and we're opening down, will we cross the x-axis? No. And so we'd have none. Okay? A little review of A and Q and how they're related to each other and how many x-intercepts we'll have. Okay, so we're going to look at situational domain and range a little bit today. So domain and range will be restricted when we have a context, like a word problem. For instance, if we have number of jelly beans, they can only be whole numbers, and time cannot be negative. So let's look at a word problem. So you're going to have a question like this on your quiz and unit exam probably, where it has some context. Okay? So here's a diver dives off a diving board. Her height in meters above the water is given by. So there's an equation, there's decimals in it. I know I'm just going to have to punch this into my calculator. So that's my first step. Let's punch it in. And then we're going to have to play with our windows, and that's always fun. Everyone's favorite thing to do. Okay, so if you have standard windows, you're not really seeing anything, are you? Well, what's our y-intercept? It should be 12, right? So we know we're gonna have to go higher. How high do you want to try going? 20? Sure, let's try 20. And we know we're gonna have to go more positive for the x because we didn't see the x-intercepts. So maybe we'll try that. We'll make that time of 20 as well. See if that helps. Push graph. So I'm going to make 20 and 20. Did your graph show up? Oh, I forgot a square value. That's important. You think? Let's try that. There we go. So you did see something. That's not good. We need to go much higher. What did I do? Okay, negative 4.9 x squared. Good. Plus 5.5x. Good. Oh. I put my square. What happened? I didn't delete my other equation. That's why. That's why you should clear your other equation, not type over top of it. Lesson learned, okay? Learn from my mistake. Does yours look something like that? Oh, good. So you didn't need to make your x bigger, did you? When it was 10, it was a little bit better. In fact, we can go smaller. So let's talk about this problem. Are we going to have negative values here with height and time? No, we don't need the negative, right? We don't want it negative. So I'm going to look here and go -1 for my min. My maximum, I had all that extra space. So let's change that to maybe 5. I didn't need so much. And my y min, I'm going to go -1. And 20, I think, was okay. Right, so that's what I'm going to use. And push graph. A little bit better. I still could probably trim off some x and y, but I don't have to. That's good enough. I can find my max nicely, my x-intercepts nicely. We're good. Okay, so it says, what is the maximum height? How do we find that on our graphing calculator? Did you want me to dim the lights? I feel like you'll fall asleep if I do. Second trace. Number 4, left of the vertex. So this is the left side of the vertex. And right of the vertex. I'm just going to push enter for my guess. I don't think guess matters at all. Did you get the same thing? 0.56 and 13.54 approximately? Yeah, your guess does not matter. So it was, our vertex was, I'm just going to write this down because I'm probably going to have to need different parts of it later. 0.56, 13.54. Okay, so what's the maximum height? Which one of those are we going to use? 13.54 what? Meters. Make sure you have units in these questions. What time does the maximum occur? That's why I wrote down the vertex. When does it occur? 0.56 seconds. What is the height of the board, the diving board? So the height of the diving board is at what time? When time is what? 0. It's your starting point. So when time is 0, we want to know the height. So on our graphing calculator, or if you look at our graph, what part of the graph is that? The y-intercept? Yeah. So how do we get that? Trace 0. Enter. You guys are like the quietest people ever. Okay, trace 0, enter. 12. 12 what? Meters. Okay, what time does a diver hit the water? Now what do we want? And this is why I went, instead of just going to 0 for my, when I made my, I had like -1 and -1, because I knew I probably would have to find this x-intercept. That's when he hits the water. So I need to go below it and above it. So that's why I like to keep a little bit of the negative, just so when I'm doing above and below, finding my x-intercept's a little easier. Second, trace number 2, left side. We haven't even got to the tough problem yet today. So left bound. Now we want to go the right side, so below, enter, and then guess doesn't matter. So you should get 2.22 seconds. Did you get that? Yeah? Okay. How high did the diver get above the board? How could we find this out? Yeah.
Take a maximum height and take away the height of the board.
Okay, and that equals 1.54 meters. Good. So domain for this context. Now this is the what's new and what's tougher about this. The domain though of this graph, when you look at it, because we don't have negative, we're just describing our height above the water. We don't have negative time, and once we hit the water, the graph ends. We're just graphing the height above the water. So our domain is between what two values? Okay, you're thinking of y. So we're doing x. What variable is x in this context? Time. Can you have negative time? No. So we're starting at 0 until when? What's this point? 2.22. So when I write my domain, I can't use x. What variable would I use? T. So t is between 0 and 2.22 seconds. And so how do we say it's between? Our arrows both point left. And the reason why they both point left is because time is greater than 0. And then if you cut out the other, our time is less than 2.22. Okay, so that's the domain. The range, how high do we go? If we look on our graphing calculator, how high did we go? 13.4. What's the lowest height in this context? It's our 0. Be very careful. Often students will put their y-intercept. No, we actually go all the way to 0. So it's between 0 and 13.54. And the variable for range was the height. Right. All right. Let's look at, so I gave you a quiz on Friday that was maybe a little preemptive, maybe a little too soon. A lifeguard at the beach has 200 feet of rope. So these type of questions you're going to see a lot of. They're going to take practice, and the more you do them, the easier they get. Okay? So it says a lifeguard at the beach has 200 feet of rope to section off a rectangular swimming area along the beach. So one thing they don't say, which I should have maybe been more clear, is we're not actually needing rope along the beach, just in the water. Right? So here's the beach, and here's the water. Okay, and we want to put our rope, section off a good rectangle in the water for swimming. Write an equation to represent the area of the water that the rope can be created. So area, how do we find area of a rectangle? Length times width. Now here's the problem, okay? This equation has 3 variables. We only want an equation with 2 variables. So we need to eliminate L or W somehow. And that's where the 200 feet come in. What does the 200 feet represent? Well, this beach has 2 widths and this sectioned off area, right? The rope is made with 2 widths and 1 length. And what will all of these add to? 200. That's 200 feet of rope. So we know that, and where am I going to write this? I'll write this here. 200 is equal to 2 widths and plus 1 length. And so we can rearrange this, change my area formula, so we only have 1 variable. We're going to replace the L or replace the W. It doesn't matter which one, it's up to us. Who's the easiest to isolate for? L or W? L, because it has a coefficient of 1. So let's get L by itself. How am I going to get L by itself? Subtract 2W to both sides. And so I can actually rewrite this formula as L equals 200 minus 2W. So now we can make our area equation with only 2 variables, the area and 1 other variable. And how we're going to do this, we're going to replace the L with 200 minus 2W. We know what L equals now. So area, we're going to change to 200 minus 2W times W. So we replace that L. Does that make sense? You did this in grade 10 a little bit, right? A little bit at the end of the year. Most of you didn't like it, I'm sure. Okay, so there's our equation. We can actually simplify it by distributing the W in. There's not enough room here. I'm so sorry. So area equals negative 2W squared plus 200. I'm going to rewrite it in the normal form. So instead of 200W minus 2W squared, I just rearranged it. Put the W squared first because it's better to have it highest degree to lowest. In math, that's what we like to do. Okay, so there's our equation. Now we can type it in our calculator. Grab your calculators. Now, in the next coming days, we're going to learn how to solve this algebraically. But for now, we're just going to practice making the equations and solving it with the graphing calculator. Because the hardest part is making the equation, really. So negative 2x squared plus 200x. And let's reset our windows. How do I do that? Let's do zoom 6. Oops, don't push it. If you've ever seen, like, do this, it's thinking. If it ever, like, stops moving, it's because it's paused. Just push enter again. Okay, you can't see anything. Do we all not see anything? Did I type it in wrong? Okay, good. We're good. So we know that this graph is going to be, we need to see more of this graph. We need to zoom out. Let's just use the zoom feature this time. And go zoom number 3. Nothing will happen until you push what? Enter. Good. Do I see my graph? No. So then I'm going to push enter again. I don't have to go zoom 3 again. I can just push enter again. Did you see it? Oh, we're starting to see it. We can push it one more time if we want, because I don't really see it. I need to see the vertex. What? This zoom is not really good, hey? I don't like it. Okay, zoom feature, not good. We're going to do it ourselves. Boo! Okay, what windows? Oh my gosh. Okay, let's go back. Zoom 6. Zoom feature did not work well for us. We're going to change our windows. We know for this, can you have negative length width and length? No. So we can change those to zeros. X max. Well, if we think about this, our width is we have width and length, right? We have 200 feet of road, so we know it has to be less than 200. You can't have a width. In fact, it has to be less than 100. Our width value, because you have to add these 3 together, and they have to add to 200. So let's try 100 for our max. On a scale of 10. And our area is our y. Now area, if this was 100 times 100, right, let's just say, no, it has to add to 200, right? So let's say it was like, I don't know, 50, 50 and 50. No, that doesn't add to 200. 50 and 75. What's 50 times 75? Because it's area, right? So approximately 50 times 100, let's round it. 50 times 100 is 5,000, right? Because it's area. Our y variable is area, so we need to go pretty high. So I'm going to go, negative 10 doesn't matter if we're going up to 5,000. It's essentially 0. I don't know, I'm going to try 2,500, maybe? Maybe 5,000 is too big, I don't know. Or 5,000. Let's try 5,000 and see how it goes. And I'll go a scale of 1,000. No, 500. Is that better? Yay! Look how beautiful that is! Wow, we got lucky. I love when that happens. It's gorgeous. Can you ask for a better graph? I don't think so. I don't know. Okay. That's so beautiful. So what we did was, I'll show you my windows again. 0 to 100, scale 10, and then 0 to 5,000, essentially scale 500. So gorgeous. Okay, so now you have to think about your variables that you're graphing, right? We're graphing area versus width. So keep that in mind when you're making your windows. All right, let's find our maximum. So what does the vertex represent in this question? So if we're graphing area versus width, this is our area. As our width changes or increases, our area goes up, and then our area goes back down. Right? So if our width was 0, would it actually be a rectangle? No, and our area would be 0, or that wouldn't even exist, right? So as our width increases, so what would this vertex represent? This, whatever the width value is, and the maximum Maximum what? Area. Yeah, the vertex is going to show your maximum area, the width and the maximum area. Because we're graphing area versus width, right? So that's going to be the max area at a particular width. So let's find out what it is. Second, trace number for left side. I think it's going to be 50. I lost it. Left bound, come back. Right bound, enter gas. Enter 50. 50 and 5,000. Wonderful. So, what can we say about that? When the width is? When the width is 50 feet, the area is maxed, max of 5,000 feet squared. Okay. Now, in a question like this, I would actually probably ask for the dimensions. Not just what's the max area, but what the dimensions are. So if you know your widths are 50, what's your length? Has to be, and this is 200 feet of rope. 100. Yeah, so 50, 100, and 50. And so our dimensions of this rectangle are 50 by 100. So domain of this, okay, what's the domain? Oh, I hate doing the domain. Okay, let's talk about the domain. Okay, so this was 0, this was 100 here, right? So the domain is for width. Between 0 and 100. Now my question for you is, can it be equal to 0 or 100? Can the width be equal to 0? No. Can it be equal to 100? If this was 100 and this was 100, what would be your length? 0. So that's not possible. So our domain would actually be between 0 and 100. It wouldn't have the equal to symbol, because if you had it equal to 0 or 100, it doesn't actually, it's not a rectangle anymore. It's just two lines. It doesn't make a rectangle. The range is our area, and our area goes between 0 and, what's the maximum? It can actually equal the maximum. What's the maximum area? 5,000. Okay. So assumptions we're making is that we're using all the rope. And that all widths between 0 and 100 are available. And what I mean by that, in a real life context, maybe there's a rock in the way or something, right, inhibiting you from using a certain dimension. So we're assuming that we can use anything between a 0 and 100 for our width and lengths. Between 0 and 100 for our length. Okay? And it's also assuming that maybe like this depth, that we're okay with any depth of water. So if we're actually roping off an area in the ocean, maybe we wouldn't want to do the maximum area, because maybe there's a depth that would make it go too far out, right? So certain assumptions are made. Okay, let's try one more like this. I want you to try and make the formula. I'll get you started, but you're going to try and make the formula. So a farmer has 1,000 meters of fencing and wishes to build a rectangular holding pen. So there are 4 equal pens as shown. Like one's for your pigs, right? And one's for like your chickens or something. I don't know. So different pens. Are roosters? That's supposed to be a pig, but I don't know if it looks like one. Okay. So, what do we know about the dimensions here? How many lengths will we have? 2. A length and a length here for my pen. How many widths? 1, 2, 3, 4, 5. 5 widths. It says write a function for the area. So again, the area of all the pens together. What would be the formula for the area of all of this? This big rectangle. Area is length times the width. Yeah. So our area for the whole thing together is length times width. Problem, we have 3 variables. We only want 2, area and length or width. So, how else, what's the other equation going to be? Not area, close. What is it actually, when we're talking about adding these all together, what's that called? Not area. What do we call that when we add all the sides together? Perimeter. So perimeter is equal to what? How much fencing do we have? So 1,000 equals what? And then you said the rest is good, Marcus. So 1,000 equals 5W plus 2L. Okay. Maybe we should do this together so we solve for the same variable. Who do you want to solve for? The W or the L? L. Okay, let's get L by itself. First step. Subtract 5W. So 1,000 minus 5W equals 2L, then divide it all by 2. I find it easier if you just leave it individual. Divide every one by 2. So what's our formula? 1,000 over 2 is? I know. I feel you. 500 minus 5 over 2W equals L. So now that we have our two equations, right? We're going to take that second equation and sub it into the first, our area formula. So area equals, and I'm going to replace L with, what's L equal to? (500 minus 5 over 2W). Okay, distribute the W, and there's our formula. 500W minus 5 over 2W squared. If you want to rearrange that, you can put the W squared in front. That doesn't matter. I want you to graph this to find the vertex. So I want you to try plugging this in and figuring out your windows. So think about area versus width here. Okay, we know there's a maximum of 1,000 meters of fencing. So if you estimate area being, okay, what if it was 500 and 100? 1, 2, 3, 4, 5. So that would be 500 times 100 gives you your max area to estimate.